Howdy Bubs and welcome back. Today we're going to be jumping back into GameMaker, taking a look at how to add in some boundaries to movement and creating a bouncing ball inside of our room. So, first up, in terms of new things that I added off screen, I created a ball here. I added little markings just so I can know what the front is. Very simple. The most important things to do is first make sure the origin point is set to the middle, so middle center, and then over on the left side you're going to click on collision mask, and where it shows type you're going to go to ellipse slow. If you do not do this, you're going to run into a few problems later, so make sure you get this addressed now. You can of course create your own alternate sprite image for the ball. You can add in animations. As long as it stays more or less in this shape of a ball, everything should be perfectly fine. First up, I'm going to want to ensure that our player cannot leave our room. So, I'm simply going to add in some restrictions on how our player can move around. Currently, we have x is equal to x plus 5. However, this is as we move towards the right. I do not want my player to move off the screen, so I'm going to simply bound it. I'm going to put parentheses around here, and I'm going to call a function, min. Min specifies it will only take the smaller of these two numbers. So I'm going to take the smaller of the two numbers of x plus 5, or whatever your distance, speed, change in movement is, or room underscore width. This means that our x value will be the smaller of these two, either whatever it's shifting over to, or the width of our room. This will ensure that it will never go past our room's width. This addresses it for the x value moving towards the right, up to our room width. You need to figure out how do you ensure that you bound it correctly towards the left, the top, and the bottom. Just as a hint, in addition to min, there's also max. Max is the opposite. It takes the larger of the two numbers. You're going to have to use both of these to address all four directions. So I'll let you go ahead and work on that one. In regards to our rotation, here we have our image angle for rotating clockwise. It'll be bounded up to a certain point. Depending on how we want to do this, I've got a little drawing here just to clarify some things. 0 degrees is treated as being over here facing towards the right. 90 degrees is upwards, 180 is left, 270 is down, and 360 brings us back to facing towards the right. I want to bound ourselves here in this upper facing portion just for our rotation, just to mess around with some stuff. And so I can only rotate up to, I'm going to say 45 and no more than 135. We'll just play around with that here. In order to implement this, we're going to have image angle is equal to image angle minus 5. We can implement the same concept. If I press right, I'm rotating downwards just to show the use of the other function max. Here I'm going to say max, and I'm going to take whatever my current image angle is minus 5 degrees, or in this case, if we're looking at our drawing here, I'm subtracting 5, I'm going to be returning towards 0, so I want the cutoff to be 45. So that means the largest value of these two will be accepted. Either our current angle minus 5, or if that becomes too small, then 45. That way it doesn't go too far. Let's go ahead and take a look at what this does inside of our room. So here, as soon as I press right, it's going to update this to ensure it's locked at the correct position. As you can see there, it can't go any further. And if we hold down right, our block is going to get capped there at the edge. But notice half of the block has gotten capped at the edge. This is referenced based off of our center point, or the origin of our sprite. Over in our movement for left, right, up, and down, we have to add in a little bit to compensate for trapping it inside of the room. To make sure we compensate for that, rather than having the cutoff being the very edge of the room, I'm going to be referencing information about the size of our sprite. So it's the room width, in this case since we're on the right side, minus sprite underscore width, and since my origin is in the middle, divided by 2. This will ensure that as we move towards the right, we don't go off screen. Again, the origin point for my sprite is in the middle. The origin point for your sprite should also be roughly in the middle. As I move towards the right, we're now capped here, because from 0 all the way to room width, we're adding our X position plus half of the width of our sprite, and so it capped it off right here. So now your challenge is to implement both the movement and the rotation. It may take a little bit of messing around with, and you can always modify the boundaries depending on what works for your sprites, your character, and what you're wanting. But this gets us started on this step. The next challenge is making sure that the ball can bounce around the room. I'm going to create a new object. This is going to be obj underscore ball. This is going to select the sprite that I created earlier. And we're going to create 3 events here. First, in our create event, this portion is simply going to randomize direction and set a few other values. I want the ball to have a random starting direction. So using the iRandom range, we're going to use iRandom underscore range, and we're going to specify a boundary between some values. In this case, for starting off the ball's bouncing direction, I'll have it capped between 45 and 135. You can play around with these numbers, whatever seems best for you. And a starting speed for our ball. I'm going to say 10 pixels per second. These are 2 special values tied to objects. These properties define, first, the direction that we are currently moving towards, and the speed at which we are moving in that direction. This does not necessarily line up with the sprite unless you tell it to do so. Over in the step event, we then clarify, so face direction, we then clarify that the image underscore angle, the angle that our sprite is currently rotated at, again initially at 0, is going to match the direction of our movement. So just to demonstrate this portion, we can go over into our room, place the ball down, and whenever we hit play, we'll be able to see the ball randomly move off into a direction upwards. It will always move in the same random direction unless you add in one other line in our create event. The reason it does this is so that you can easily test things. If you include randomize, this will properly randomize the seed and ensure that different things happen each time you run. If you want to make sure everything's working correctly, usually people will turn randomize off. And that's as simple as just putting 2 forward slashes. It makes this line of code not work. It turns it into a comment. But just to demonstrate that it is in fact random, I'm going to place this here. And so now it runs off in the other direction. Play it again. It should now be in another direction. And there we go. Within this boundary. You, of course, can change this boundary to be whatever you want. I've just locked it between these 2 values. Again, the meaningful values are 0 all the way to 360. The last event, in order to make sure that the ball bounces around correctly, is going to be a intersect boundary event. This is under other and the intersect boundary event. So this will address when the ball hits one of the edges of the room. So for our case, this is going to address bouncing. This portion of code gets a little bit more complicated, and so I'm going to walk through it with you. I'm essentially going to say if the boundary box on the left side of our sprite is less than 0, meaning that we have gotten to the edge of the room and the left side of our circle of our ball is touching the edge of the room whenever we're in the game, I want this to then change my horizontal speed. Speed can be broken down into 2 separate components, horizontal and vertical. And I want this horizontal speed, whatever it might be, to become the opposite of its current value. If it's positive, flip it to negative. If it's negative, flip it to positive. This will address moving towards the left, but I also want to address moving towards the right. So I can say or boundary box of the right side of our sprite if this goes out of bounds on the right side of the room or room width. I also want it to perform the same action here. So if the left side touches the left side of the world, so 0, or the right side touches the right side of the room, then the horizontal value needs to be flipped. You also need to implement one for the vertical direction. Just as a hint, you will be using vSpeed. You'll be using the vbox top and vbox bottom, so top and bottom. And I'll let you see if you can figure out the relationships between the different numbers or values that you'd use to bound it correctly. Just to demonstrate that this portion is working here, I'm going to force this number to be 0 so we can see it bounce towards the left and right. And there we go. It bounces left and right. However, whenever I remove this portion and run it, we will see that it will not bounce top and bottom correctly because that portion of the code has not been written. That is your challenge. So go ahead and figure out how you can bound our rotation as well as our movement for left, right, top, and bottom, as well as locking the rotation between 2 values. Again, values could be your choice. And then getting the ball to bounce around the screen correctly. If you have any questions in class, just let me know. Otherwise, that's all I've got. Everyone have a good one. I just wanted to say thank you to all of my Patreon supporters. Shout out to my bad bubs, my top 5, my day ones. Y'all have always been there for me. Next up, my baby bubs, the next 5. I always love y'all's support.
And finally, for everyone else, any little bit helps. Thank you to all my basic bubs for supporting me along my journey. If you want to continue receiving notifications, make sure to like, comment, and subscribe, and don't forget to hit that bell button.